First of all, I would like to thank the organizers for the opportunity to be here, and it's a great honor, of course, to share some perspectives on Professor Yang's many important contributions to physics. Let me start with Professor Yang's select papers. It was first. Sorry. It was published in 1983 in Freeman, but in 2005 it was reprinted by World Scientific, led by Professor Poor. And recently there was also a sequel to it on papers written more recently. Here is a passage from the preface to the select papers, of course written by Professor Yang, by the author. He mentioned that, he said that a scientist is not expected to give a balanced assessment on his papers, but he is the one who knows the stories best. I think it's very nice to quote this at this moment. Okay. Especially he quoted 2 lines by a famous Chinese ancient Tang Dynasty poet, Tu Fu, and it reads, a piece of literature is meant for a millennium, but its ups and downs are now already in the author's heart. Yesterday, Professor Zhu Bangfen had already shown this to you. This is a gift to Professor Yang. It was inscribed with his 13 important contributions. On each of the 4 phases, there was inscribed the contribution in one of the 4 fields, namely condensed matter physics, statistical mechanics, and particle physics, and field theory. And on the top, it's just the 2 lines I just read. Okay. In the following, let me lead you to make a brief overview of these 13 contributions, but I slightly make a different order. I put condensed matter and statistical mechanics all together because it's better to do it chronologically for these items. And then it's 4 contributions to particle physics, followed and last by Professor Gorge's contributions. Okay, let me start with 1952. Professor at that time just moved from, recently moved to Princeton. In 1952, he published 3 papers. One is magnetization of 2-dimensional Ising model, and the next 2 is the extension to lattice gas. I believe Professor Michael Fisher will make a more in-depth review of Professor Yang's contribution to statistical mechanics tomorrow. Let me remind you that this is the longest calculation Professor Yang ever did. And let me mention that Mr. Chang followed Professor Yang's suggestion to do a calculation on the rectangular lattice and obtaining the same critical index, so 1/8. So this was probably the first indication of universality. And then T.D. Lee came to the Institute for Advanced Study under the recommendation of Professor Yang to Oppenheimer. And so naturally they started a collaboration. They extended Professor Yang's work on Ising model to lattice gas, then computed rigorously the Maxwell diagram. And a very famous part of these 2 articles is a unit circle theorem, which Professor Yang himself called minor germ. And this work settled the debate and since Mayer's 1937 paper as commented by Max Born and Klaus Fuchs as how can the gas molecules know when they have to congregate to form a liquid or solid. So I looked at the Web of Science citations. This is the citations for these three papers put together. So you can see the number of citations actually were with fluctuations, but the general trend is always increasing. Compared with the usual case, it's really an anomaly, because usually we talk about the half-life, the decay of the citations. And let me mention the vertical coordinate is a number of citations for each year. Okay. The next famous contributions is 1957 one to bosons. Actually, Professor Yang and his collaborators wrote quite a few papers on this subject. So here, only two represented ones are chosen. Okay, in physical review. Okay. This photo actually from the blackboard you can recognize is a calculation on those papers. In this work, this work is well motivated by physics. So it's at that time Professor Yang got interested in superfluidity of liquid helium, and also this work is mathematically well defined. They work on dilute hard sphere bosons, at that time, Professor Ke-Seng Huang introduced Professor Yang to the Fermi's pseudo-potential idea, and they obtained the first two terms of the asymptotic expansion of the sound velocity. Remarkably, in more recent years, so actually 50 years after the work, it became very important, experiment very important, because they were studied in cold atom systems. So this is citation to this paper. There is some peak shortly after their publication, but it decayed, and then started in 1990, started increasing again, okay, because of experiment breakthrough, of course. So then in 1961, Professor Yang published a paper on the flux quantization of superconductor. So this is at that time Professor Yang was visiting Stanford. So this is an example of Professor Yang's interaction with the experimentalists. And they in Stanford, the Fairbank obtained the HC over 2E quantization of the flux. So Professor Yang and Nina Byers of Stanford, they show that this flux quantization is a consequence of BCS pairing. Okay. So this is a citation, and a very pronounced peak appeared later, some in 1990s. Of course, there is some peak immediately follow their publication, but there is a much more pronounced peak, and it remained highly cited up to now. So this is probably an indication of the activity in this field. Okay. Then in 1962, Professor published this paper on off-diagonal range order. In this work, Professor Yang used off-diagonal range order to unify the superfluidity and superconductivity. And this is a paper Professor Yang always been fond of. And let me mention, in recent year, Nobel laureate Tony Leggett has a book, published a book. In this book, this book was written under the viewpoint of Professor Yang, namely using the reduced density matrix of one or two particles. Okay. That's off-diagonal range order here. This is a citation. So there is a peak around 1960s, but then there is a highland in more recent years. Okay. This is an indication of many activity now in quantum condensation phenomena in condensed matter, in cold atom, and etc. Then in 1967, after Professor Yang moved to Stony Brook, Professor Yang published this paper later called Yang-Baxter equation. This paper this work was initiated by Professor Yang's search for off-diagonal range order model. And then it resurrected Professor Yang's interest in beta enzymes. This work opened the door to Yang-Baxter equation, of course, and also to 1D fermion. 1D fermion, amazingly, it now becomes a basis for many 1D cold atom experiments nowadays. So we see many of Professor Yang's Professor Yang's work have some now are related in cold atom field. So this is a citation. There is a pronounced peak in 1990s, and then increased up to now. Okay. The next one in the 13 contribution is the 1969 one on finite temperature. In this work, Professor Yang and C.P. Yang, they give the first exact solution at finite temperature. And again, it was now very relevant in cold atoms experiments. Okay, this is citation, and much more nowadays. Okay. So now we came to particle physics. Okay, of course, the most famous work is Professor Yang's work on the parity and conservation with Professor T.D. Lee. In this paper, they question, the title is a question of parity conservation. Okay. Initially, Professor Yang wished to use the title, is parity conserved in weak interaction, and later in published version is question of parity and conservation. Okay, by early 1950s, parity conservation was regarded as a very attractive natural secret and also useful. So this naturally, this paper met with universal disapproval, okay, and even ridicule. I think in early 1957, we know Professor C.S. Wu announced his experiment result, and then Yang Li work was immediately awarded Nobel Prize at the same year. Okay, unfortunately, Professor Wu did not share it. So this is the highest speed of recognition as far as now in all history of Nobel Prizes. Okay. Is it right? So this is a citation plot. Okay. Of course, because of this dramatic revolution, there is immediately a high peak in 1957. But also, it's interesting to note that in more recent years, it started to increase. After Professor Yang and T.D. Lee's this paper was written, they received a letter from Ohm. So as a consequence, these three people, they discussed the relation among these discrete symmetries. So in this paper, they discovered the relation among C, P, and T. This paper has had a decisive impact on theoretical analysis later on when CP violation was discovered. So there was a clear peak following immediately, and also there was a more pronounced peak when around 1964. In 1960, Lee and Yang published this paper, a theoretical paper on neutrino experiment. This follows the experiment that is Schwartz's suggestion of using high energy neutrino beam to study weak interaction. In 2005, Professor Steinberg he commented that the physics interest of such experiments were tabulated in a paper by Li and Yang, and that proved prophetic. And these processes became topics of extensive experimentation in the following years as when neutrino beams became increasingly powerful. Okay. So we see a clear, pronounced peak following this suggestion. In 1964, immediately following the experimental discovery of CP violation, they, with Professor T.T. Wu, who is here, they made the phenomenological analysis of the CP violation. And as commented by Cronin in 1993, they say among those theoretical papers of 1964, only 2 papers were still quoted at that time. One of them is this paper by Yang and Wu. Actually, together with Li Yang 1957 paper, this paper defined the vocabulary which still is being used today. And again, Steinberg recalled that it was just this paper inspired him to make the measurement of the parameters in neutron kaon case. So this is a citation, and also similar to the previous one, it was a pronounced peak in, after 1964. Okay, now let me come to Professor Yang's greatest contributions, gauge theory. Actually, there at that time, at that year in 1954, there were 2 papers in Physical Review. One is just an abstract of Professor Yang's talk in April meeting of APS. The other is a more well-known one. Actually, the motivation is very well written in the short one. Let's say electric charge serves a source of electromagnetic field. An important concept in this case is gauge invariance. That's close related with equation of motion, existence of current density, and possible interaction between a charge field and electromagnetic field. And then we have tried to generalize this, the concept of gauge invariance to apply to isotopic spin conservation. In the detailed paper, the abstract says, with emphasis on a different aspect, let's say on principle of invariance. It's pointed out that the usual principle of invariance under isotopic spin rotation is not considered with concept of localized field. And so then they explore the possibility of having this under local isotopic spin rotation, and this leads to the principle of isotopic gauge invariance. Okay. So Yang-Mills theory is generalized the connection between abelian gauge invariance and electromagnetic interaction to a non-abelian gauge invariance to a new type interaction. As everyone knows, this, together with the later development on spontaneous symmetry breaking and asymptotic freedom, led to a standard model. So Yang-Mills papers, they knocked at the door of the principle called symmetry dictates interaction, which has been the spirit of the main conceptual advance of theoretical physics in the last half century. And as you would agree, will continue to be a general guidance for future developments. Let's have a look at the citation. Okay, there is a huge peak, but some years after the publication, of course. But notice that nowadays people usually not necessarily cite the Yang-Mills paper, just like people do not cite Einstein's 1905 paper when they talked about special relativity. For the later development, let me quote some Nobel lectures. Okay, the later development of Yang Mills in Nobel lectures. Let those Nobel laureates speak for us. Gasho, he emphasized the standard model based on local symmetry principle, and which was generalized in 1954 for non-being. Weinberg, it says the extension to more complete groups was made by Yang Mills in 1954, and so our present theory can be understood as a consequence of the symmetry principle and the principle of renormalizability. 1999, Veltman says he concluded that Yang-Mills series are probably the best one can have with respect to renormalizability, and so there he started a study of the diagram of Yang-Mills series. His student Tuft, he said in Nobel lecture, he said in 1971 he tried Yang-Mills theory, and QCD is a Yang-Mills theory with gauge group SU3. 2004, David Gross, Tuft's work on renormalizability of Yang-Mills theory reinforced non-abelian gauge theory, and we decided to calculate beta function for Yang-Mills theory, and Polisser also started with his calculation, and then the abstract he quoted his abstract of the paper. It's shown that the wide class of non-abelian gauge theories have up to logarithmic correction a free field asymptotic behavior, and the Polisser's abstract says explicit calculation shows perturbation theory to be arbitrarily good for the Green function of any Yang-Mills theory and many Yang-Mills theories with fermions. And 2008, Nambu, SU2 non-abelian gauge theory, Kobayashi, in the framework of the gauge theory, flavor maxing arrived from mismatch of the Masukawa also recall that they studied the SB variation in the actual weak unipart theory. The 2000 most recent angered, so they say as a valid theory of short-range interaction, we were naturally driven to take the generalization of QCD, known as QED, known as Yang-Mills theory, and transmute long-range interaction to short ones in the context of Yang-Mills theory, suffice to give this generalized photon a mass. And then he talked about the local symmetry and Higgs, similar. He say the gauge theory save the Nambu's program. Let me conclude the quotation by quoting Fermat Dyson. Say the discovery of non-abelian gauge theory was laying a foundation for new intellectual structure that have taken 30 years to build. And the nature of matter, as described in modern theories by experiment, is a super non-abelian gauge theory held together by the mathematical symmetry that Young first conjectured 45 years ago. And then in 1974 and then 1975, Professor Yang studied the integral formalism. And let me mention that back in 1954, Yang and Mills was motivated by physics and did not notice the geometrical meaning, those mathematical meaning. And around 1970, Professor Yang devoted himself to the integral formalism. And this is citation. And together with T.T. Wu, they put forward this famous dictionary, which gave the correspondence between mathematics and physics. And this induced the reunion of mathematics and physics, okay, as Michael Artel recalled. And yesterday, Mac Banquet, Professor Fadif mentioned the Yang-Mills theory is best example of mathematical principle. So Professor Yang has emphasized his appreciation of mathematics, and this is citation. And let me classify the impact among these 13 contributions to two types. One is those typified by those particle physics contributions. They have immediate many citations, and but there is a type 2 which have much more impact many years later. So these statistical mechanics works belong to this type, but also Yang-Mills theory. So you see two extreme cases. One is on phase transition, as I already said, and also Yang-Mills theory. You have this great impact. Okay, so if you search in Web of Science by using Yang-Mills as in the title, it gives 5,000, and if you using as a topic, it gives 14,000. Okay. So there's some more citation data. So those 13 contributions about half attract about half of all the citations of the paper of Professor Yang. Okay. So and also in 2015. Up to now in Web of Science, but there is always a delay between the real publication and the Web of Science. But anyway, all of the papers in the 13 contributions, except one, will already have been cited. Okay. So this is total citation of the 13 contributions and the total citation of all the papers of Professor Yang. So we see. There is a peak in 1957, and the number of citations. So it's actually really as the speed of citation. So like the universe, Professor Yang's citation is accelerating. So what's the energy that drives this acceleration? So this brings us to the characteristics of Professor Yang's work. As yesterday, Professor Paul Chu already mentioned, Professor Yang has a distinctive style and taste, originality, and elegance, and power, and physical relevance. And Professor Yang pay great attention to both the experimental facts and the basic structure of physics, and also the beauty of theoretical form. And he kept close to his own thoughts, his ideas, and intuition, rather than follow fashions or bandwagon. Okay. So once in the conference, Professor Yang was hailed as a lord of symmetry. Indeed, more than 2/3 of the 13 contributions are about the relationship between physical phenomena and algebraic and geometrical symmetries. So symmetry is a dominant theme of all of Professor Yang's papers and lectures. Let me mention that Professor Dyson recently published also in World Scientific collected papers of recent years. It includes a lecture titled "Birds and Frogs." So it says that Yang took Wild's place as the leading bird among my generation of physicists, with the non-engaged fields generating non-trivial Lie algebras. The possible forms of interaction between fields become unique, so that symmetry dictates interaction. This idea is Yang's greatest contribution to physics. It is a contribution of a bird flying high over the rainforest of little problems in which most of us spend our lives. It also included the now famous article titled "Unconservative Revolutionary." It says Professor Yang is, after Einstein and Dirac, the preeminent stylist of 20th century physics, and also says he's a conservative revolutionary. So why conservative revolutionary? So in the preface, in the introduction to this book, Dyson recently wrote, item 3.3 is a banquet speech celebrating my friend Yang Chen-Ning on the occasion of his retirement from Stony Brook in 1999. I called attention to 3 outstanding qualities of Yang that are rarely combined. First, a marvelous mathematical skill. enabling him to solve technical problems. Second, a deep understanding of nature, enabling to ask the important question. Third, a community spirit, enabling him to play a major role in the rebirth of Chinese civilization. Together, these three qualities make him what he is, a conservative revolutionary who values the past and leads to the way to the future. So let me finish by quoting again the poem of Tu Fu and making a slight adaptation. That's Yang Miao theory is a means for the millennium. Okay. Thank you for your attention.
No comment.